Okay, let's continue from here. So I hope you to differentiate comparative advantage and absolute advantage. As we have said, comparative advantage is when we compare the opportunity cost of producing some product, and if the opportunity cost is high, then we don't produce. If the opportunity cost is less than the foreign country, then we produce it in our own country. As the example we have taken in the US trying to produce flour. Okay, so for the US to produce a flour, its opportunity cost is high. Okay, so instead of producing flour in the US, then they can use that potential, they can use that capacity to produce other things than producing flours. Okay, they can produce more computers. Okay, so if the domestic opportunity cost is less, then we produce that in our own country. If the domestic opportunity cost is high, then we buy it from other countries. Okay, but absolute product takes into consideration only one product and the necessary required factor of production for that product. And if, for example, the labor required to produce cheese is less than labor required to produce cheese in the foreign country, then we produce that in our own country because we have absolute advantage. Okay, then let's continue with comparative advantage. So even a country that is the most or least efficient producer of all goods still can benefit from trade. So this is very important. So as I've said, the US is a big economy. They can produce whatever they want. Okay, they don't need to import anything from other countries. They can produce, they can use their technology to produce goods in their own country. Okay, but the thing is, the opportunity cost of some products, okay, will be very high. So for the US to buy this from other countries is to benefit. Okay, at the same time, any country, very least developed country, can still produce something and sell it to other countries because they have a comparative advantage over the other country. Okay, so even a rich, a well-developed country with an absolute advantage in both goods will have a comparative advantage in only one of the goods. Okay, so our example here is only two goods. Okay, so that's why we're saying in two goods. Okay, so it could be more than two, but the assumption we began with is only two goods. So and you can take any country which is very much developed, can have an absolute advantage in only one of the goods, and I mean absolute advantage in both goods, but they can only have a comparative advantage in only one of the goods. Okay, so for example, the US can have an absolute advantage in producing both cheese and wine, but okay, they can have the absolute advantage, as I've said. They have the capacity to produce, but they cannot have the comparative advantage of both. They might have a comparative advantage of producing cheese, but not wine, or comparative advantage of producing wine, but not cheese. Okay, so what they have to do is they have to produce, for example, if they have a comparative advantage of wine, they have to produce more, cheese, they have to produce more cheese and import wine from other countries because they can only have a comparative advantage of one of the goods. Okay, that is where the absolute advantage is larger. Then even a poor developing country with an absolute disadvantage. Okay, so let's say Cambodia is a country which has a disadvantage in producing both cheese and wine, let's say. Okay, so you can say Cambodia has absolute disadvantage in producing both, but Cambodia can still has a comparative advantage in producing something. Okay, something other than this that the US or other countries can buy. So even a poor or developing country will have a comparative advantage in producing some type of goods. Okay, maybe they have advantage of the weather, or maybe they have the advantage of uh, labor. Okay, cheap labor. Maybe they have other advantages. Okay, so every country. That's why we say that there is no country that is not involved in international trade, because every country has its own comparative advantage. Okay, so how poor or underdeveloped your country is, they still could have a comparative advantage in producing some goods. Okay, that's why they are also involved in international trade. So you can see here, this is a numerical example. So this is a unit of labor required, okay? So for example, a domestic market requires 1 unit of labor to produce a pound of cheese, okay? And it requires 2 units of labor to produce a gallon of a wine, okay? And the foreign country requires 8 units of labor to produce cheese and 4 units of labor to produce gallon of wine. Okay, so let's see. For example, 2 units of labor to produce wine, right? So if this one person, instead of involved in producing wine, if he comes here to produce cheese, then we could have had 1 more cheese, because it requires only 1 to produce a cheese. Okay, so for example, what is the opportunity cost for a country, a domestic country, to produce cheese? Okay, then wine. So here you can divide the unit of labor required to produce cheese over unit of labor required to produce wine, which is 1/2. So this is the opportunity cost of producing cheese in domestic country than producing wine. Okay, and the opportunity cost for a foreign country is 2, because it is 8/4. Okay, so where is the opportunity cost of producing cheese lower? It is in domestic country. So this means domestic country should produce cheese more than the foreign country, because it has a less opportunity cost. Okay, you can consider here, right? 1 is to produce cheese, and this is to produce 2 people. Okay, so for example, if it is only 1 person, here we could have half gallon of wine, right? Because it takes 2 people to produce 1 gallon of wine. So if we use this 1 person to get involved in cheese production, our opportunity cost is just half gallon of wine, right? That's what it means. But if we take this person to be involved in here, because it requires less people to produce wine than cheese, then we lose 2 gallon of wine. Okay, so that's what it means in calculating opportunity cost. So we will have an example. We'll look at some examples. Okay, so this is opportunity cost example to produce an additional pound of cheese. Okay, so in the previous example, 1 pound of cheese requires 1 unit of labor. Okay, so to produce 1 more pound of cheese that we borrow from producing wine, then we lose half gallon of wine because it takes 2 people to produce 1 gallon of wine. Okay, if we take 1% to produce cheese, then you can only produce half gallon of wine because it requires 2 to produce 1 gallon of wine. So to produce an additional pound, as 1 pound of cheese requires a unit of labor or 1 unit of labor hours of work. Okay, so each labor devoted to cheese production could have been used to produce a cheese amount or a certain amount of wine in states, which is equal to 1 hour over the unit of wine required per gallon is equal to 1 over the unit of labor required for wine and gallons of wine. Okay, so which is like 1 over, okay, 1 over 2 is equal to 1 divided by 2 times 1. Okay, so that is because this is 1, this is okay, this is not so. So 1 divided by, okay, 2, because A of labor units of wine is 2, right? Over gallons of wine is 2, okay? Is equal to 1 over labor of wine is 2 times the gallons of wine is 1, okay? So this requires 1 over 2 over 2, which is 1 is equal to 2, 1 over 2. So this means to produce 1 more cheese, okay, 1 more gallons of cheese, then we have to sacrifice, or we have the opportunity cost of half of the gallon of wine that could have been produced, okay? So each hour devoted to cheese production could have used to produce a certain amount of wine instead, which is equal to half gallons of wine. Okay, so if 1 hour of labor is moved to cheese production, that additional hour of labor could have produced 1 over 2 gallons of wine. Okay, I think it's easy to understand, right? If not, and we can again say this. So let me erase this. Okay, so it requires, okay, this is 1 pound of cheese and we have 1 gallon of wine. We need 2 people or 2 units of labor to produce 1 gallon of wine. And we need only 1 unit of labor to produce 1 pound of cheese, okay? So if we want to produce 1 more pound of cheese, for example, 2, then we need 2 people, right? Because for 1, we need 1. Then for 2 people, we have to take 1% from the wine production, okay? So which means now, since it requires 2 people to produce 1 gallon of wine, we can only produce half gallons of wine, okay? And we can produce 2 gallons of cheese, okay? So to produce 1 more gallon of pound of cheese, we sacrifice, or our opportunity cost is half gallons of wine. Okay, that this is the opportunity cost we have, okay, of producing more cheese. Okay, so let's continue then. Let's talk about production possibility frontier. So production possibility frontier means it's about maximizing production capacity. Okay, so how can we maximize our production capacity? Because that is what production possibility frontier or PPF is all about. Okay, so maximizing production capacity means creating many jobs and using many resources as much as possible. Okay, so that is production possibilities about maximum production capacity. Okay, to use our maximum production. Maximum production capacity means to create many jobs as much as possible and to use many resources as much as possible. Okay, then the production possibility frontier or PPF of an economy shows the maximum amount of goods that can be produced for a fixed amount of resources. Okay, so if the quantity of cheese, QC is quantity of cheese, represents the quantity of cheese produced, and QW represents the quantity of wine produced, then the production possibility frontier of the domestic economy has the equation of this. Okay, so this means the labor required for production of cheese and the quantity of cheese plus labor required to produce wine times quantity of wine is equal to the total units of labor resources we have. Okay, that is the equation. Okay, so that is the calculation that we use in production possibility frontier. Okay, so PPF in labor constraint form is this. Okay, this is the computation. So cheese endpoint of PPF if so in the cheese point of PPF, or we have this graph. Okay, so we'll be talking about the maximum production of cheese with zero production of wine and maximum production of wine with zero production of cheese. That is the production possibility frontier. Okay, so let's say if this is a cheese, okay, and this is wine. So cheese in the point of PPF means if we produce, how can we produce maximum amount of cheese without producing wine? How much is the amount? Okay, and how much is the number of wine that we can produce if we stop producing cheese? So this will give you the production possibility frontier graph. Okay, so in the end point of the PPF, if only cheese is produced, okay, so here is the calculation, right? So if only cheese is produced means ALC times QC, quantity of C, plus labor unit of W times 0 is equal to total labor. Okay, because we are saying that if we don't produce any wine, okay, if we only produce cheese, okay, so this means so in if you are familiar with how to drive this will be 0, right? And here we have ALC QC is equals to labor. Okay, or you can say finally quantity of C produced is equal to labor over ALC, because we have to divide both by ALC, right? So this is the quantity that we can produce if we do not produce any wine. Okay, that is the cheese endpoint of PPF. And you can do the same for wine. Okay, if we have 0 quantity of cheese, then labor unit of cheese multiplied by 0 will be 0. Then we divide this by ALW divided by ALW. Then this will cancel out. Then QW is equal to labor over a unit of wine production, like this. Okay, so the two endpoints will be calculated by having 0 of each of the other quantities. Okay, then here, how can we know the slope? So the slope, you can calculate it from the graph itself, or you can use this QW computation. Okay, so you can compute QW from here, right? So if you want to know if you compute QW, what you do is you take all this to the right? So you can do ALW QW is equals to L minus ALC QC. Okay, then you want only QW, so you divide this by ALW and you divide this all by ALW, then this will cancel out. Okay, so finally what you have is QW is equal to, then you can use this as L over ALW minus LC over ALW multiplied by QC. Okay, so anyways, you can derive for the QW using the formula. Okay, so finally it will come like this. Okay, so this is the slope of the frontier. Okay, the slope intercept. So the slope of QW will be this. Okay, the opportunity cost of cheese production is the quantity of wine production that we gave up. That is this one. Okay, so which is equal to the absolute value of the slope of the ppf. Okay, so here is the graph. So as we've said, if we produce 0 of this cheese, okay, so because this one is cheese production of home and this is wine production of home. Okay, so if we produce 0 cheese, then we will produce this amount of wine, and if we produce 0 amount of wine, we produce this amount of cheese. Then finally, this is a production possibility frontier. Okay, so anything outside the production possibility frontier here is unattainable. Okay, you can say unattainable. Okay, or this is not possible. Okay, this part. So we can produce this amount of pointers. For example, we can produce this amount of cheese, and because it is like this amount of wine. Okay, this amount of cheese, and it is here, this amount of wine. Okay, so this part is unattainable, and this part means that we are underutilized our resources. Okay, so let's continue with this. Then this is an example for home production possibility frontier. So in the home country, producing 1 pound of cheese requires 1 unit labor, and producing 1 gallon of wine requires 2 units of labor. Okay, so home country has a labor supply of 1,000. Okay, now we can calculate, right? We can calculate how many quantities of wine and how many quantities of cheese we can produce, right? Because we have said this is the calculation or the formula for production possibility frontier, right? So for example, if you want to calculate for QW, okay, so because QW, to get the, or to compute for QW, you can just, as we have said, take this to this side. So it will be less ALC QC, right? And this will be cancelled. Then finally, you can divide this by ALW. This will then finally QW will be equal to, okay, L minus ALC QC over ALW, right? And this means that, this means L over ALW minus ALC over ALW times QC is similar, right? It's the same computation. So here we already are given the L amount. That is how much? 1,000. Okay, 1,000. Then ALW, the units of labor required to produce wine are 2, so divided by 2. So that is why, because this is 500, okay? Minus ALC, labor required to produce cheese is 1, labor required to produce wine is 2, okay? Times labor required, I mean quantity of cheese. So this is the computation that we can use to calculate the amount of cheese and wine a home country can produce, okay? With how much? With 1,000 labor supply, okay? So, for example, if we produce, okay, 600 quantity of cheese, okay, let's say if we produce 600 quantity of cheese, or if 600 cheese, how many wine or how many gallons of wine can we produce? You can use just this one, okay, because we have QW here, right? So that means 500 minus 1 over 2 times 600, okay? 1, this is 300, right? So 500 minus 300, which is equal to 200. So this means if we are planning to produce 600 gallons, I mean 600 pounds of cheese, then we can only produce how much? 200 of gallons of wine. Okay, that is the computation. What if we want to produce 1,000 pounds of cheese? So the same computation you use, 1,000, so this means 1, 500, 500 minus 500, 0, right? So if we are planning to produce 1,000 cheese, 1,000 pounds of cheese, then we have to stop producing wine because the opportunity cost is now equal, or is getting higher, lower than the home country production. Okay, so I hope so. Here QW in this we have this graph. Okay, so 0 cheese, 500 wine, okay, 500 I mean 0 wine, 1,000 cheese. So this is computed from this formula, right? This one, right? So it says Q is equals to 1 over 2. You can compute here. QW is equal to, we have said, 1 over 2. Okay, no. It is 500, sorry, 500 minus, like this. Oh, let me check again. Yeah. So if we produce 0 of wine, then that will be 500. I mean 0 of cheese, which is if this is 0, then we can produce 500 wine, right? And if we produce 0 cheese, we produce 1,000 cheese. Okay, so I think it's very simple to compute, right? So we can say this is equals to 500 minus QW, right? So QC is equals to, we divide by, I mean, we multiply this by 2 to cancel out this. 2 times 500 minus QW, okay? So if this is 0, QC is equals to 2 times 500, okay, because this is 0. So QC will equal to 1,000, right? So the two extremes are in producing 0 cheese, we produce 500 wine. In producing 0 wine, we produce 1,000 cheese. So this is a production possibility frontier. Then the slope is half, okay, because this is the slope, negative 1/2 is the slope of our graph, okay. So let's get back to our computation here. So I hope this is clear. So next one. So what is the most cheese home can produce? The most cheese home can produce is by producing 0 wine. So that is 1,000 pounds of cheese. Okay. And the most wine the home can produce is by having quantity of cheese 0, which will come up with 500 gallons of wine. Okay. So what's the opportunity cost of cheese production? The opportunity cost is 1/2, right? Because it is the unit of labor required to produce cheese over unit of labor required to produce wine. And we have units of labor required to produce cheese. We have 500 and we have 1,000, which is 1/2. Okay, so where does it appear in the PPF graph? It is the absolute value of the slope here. Okay, so the opportunity cost of producing cheese over wine is half. Okay, so that appears as the slope of the PPF. Okay. Okay, so this is another example. So there are so many examples. So I will take this example, then I will leave the other example for you to exercise it by yourself. So here is another example. In the United States, producing 1 unit of cheese requires 1 unit of labor, okay? And producing while producing 1 unit of wine requires 4 units of labor. US labor supply is 600. Okay, so we use the same computation. Okay, labor of cheese, quantity of cheese, plus labor required for wine, quantity of wine is equals to L. Okay, so from here you can compute, for example, how much maximum of wine or maximum of cheese a US can produce, because you can take this as 0, right? So for example, we can compute for QW here, okay? Because this is 1, okay? This is 1 QC plus 4 QW is equals to 600, right? So the total, for example, QW here is equal to 600. So we take this here, right? 600 minus QC, right? So over 4, because we have 4 here. So this means QW is equals to 600 over 4 is 150, okay? Minus what? Minus 1/4 times QC, okay? So this is our equation, okay? So QW is equals to 150 minus 1/4 times QC. So this is our slope. Don't forget that. Our slope is 1/4. And positive 1/4 is actually our opportunity cost of producing cheese over wine. Okay? So how much maximum amount of wine can a country and can a US produce? It's just by having QC as 0, which means when QC is 0, QW is equals to 150, right? Because this is our equation, 150 minus 1 over 4 times QC. If this is 0, then it means QW will be equal to 150. Okay? What about QC? You can compute from here. Then if QW is 0, then QC will be equal to 600. Okay? You can compute from this because I will take this as 0. This will come here. Then 150 times 4 will be 600. Okay? We can easily calculate like that. So it says find a graph and that is used by the US PPF. So we have a graph, okay? We can create a graph like this, okay? And we can have 150 here, and we can have 600 here. So this will be the slope, the graph of PPF, okay? I think that's clear. So determine the maximum US maximum cheese production, determine US maximum wine production, find the US opportunity cost of cheese in terms of wine. Where does it appear in the equation describing the production possibility frontier? Then we answered everything, right? Maximum production of cheese is 600, maximum production of wine is 150. The slope is negative 1.1 over 4, opportunity cost is 1 over 4, and it is all required for this, right? We have already computed this. Next, QC is maximum US can produce is 600 pounds of cheese, maximum wine is 150, okay? And this is opportunity cost, and this is also our slope, okay? Then this is our graph. So this is the slope, this is the graph, okay? I hope this is clear, okay? Then as compared to the other graph, then this is a little bit steepy. So I hope this is clear. I will be back in 5 minutes again. So stay tuned, okay? We'll see each other. I'll take 5 minutes break, okay?